Hello, this is a video about hashing. What we're going to do is we're going to look at hashing and what it is, and I've created a little example to illustrate a hashing algorithm for you. We're also going to look at some concepts called the avalanche effect and hash collisions, and then wrap up the video by looking at secure hashing algorithms. So what is hashing? Hashing is a function or hashing algorithm that takes plain text or a file of any length and uses it to calculate a short code called a hash or cryptographic hash. Every bit of the plain text is used to create the hash. The hash is fixed length, no matter the size of the original plain text. And interestingly, there is no backwards function that can start with a hash and reproduce the original plain text. So the function is truly a one-way function. So let's set the scenario. Suppose I've got a purchase order that I want to transmit to a company computer. How do I know that the purchase order that I transmit is the same as the purchase order that the company receives? How do I know that the file was complete or was not altered while in transit? Well, back in the olden days, about 40 or 50 years ago, computers sent two of the same file. So when the company computer would receive the purchase order files, it would compare them letter by letter, number by number, and if there was no discrepancy, then it would assume that the transmission went successfully and there was no alteration of the purchase order. Another method, back in the olden days again, is that the purchase order would be transmitted with a second file called a batch total file. And a batch total file would be just some numbers that were created as the sums of some numeric values in the purchase order. For example, I could sum up product numbers. Now I know this doesn't mean anything. I could sum up all the quantities in the purchase order. Put these sums in a separate file called a batch total file, transmit it along with the purchase order to the company computer. The company computer would calculate its own batch totals, and if they matched the ones that I sent, then it would know that everything was transmitted and received with no problems. Nowadays, we transmit the original file, the purchase order file, and the second file is a hash file, and it's created by a hashing algorithm. I've created a very simple example to show you what is involved with a hashing algorithm. Suppose I've got my purchase order that I want to transmit, but before I transmit it, I create a program called a hashing algorithm. And here's what the program does. It looks at the purchase order, and every time it sees an A, it substitutes the number 1. Every time it sees the letter B, it substitutes the number 2, all the way down to the letter Z. Also, every time it sees the number 1, it substitutes a 5. Every time it sees a number 2, it substitutes a 6, and so on. I think you get the idea. We end up with a bunch of numbers, we add them up, and we calculate 549640305939. So I would transmit my purchase order file along with this hash file that I newly created to the company computer. The company computer would take the same hashing algorithm that I created, come up with its own hash. If its hash matches my hash, then it can be assumed that the file was transmitted and received without any problems. What would happen if the purchase order was altered in any manner during transmission? In other words, suppose I send my purchase order in my hash file and something terrible happens to the purchase order. It becomes a sales order and products are changed and quantities change in transmission. Well, when the receiving computer receives my purchase order, it will run it through the hashing algorithm and it will come up with a completely different hash total than what I transmitted. And in this manner, it would know that there was a problem from the time that I sent the purchase order to the time that it was received. This is known as the avalanche effect, which means that even the tiniest change in the originating file, for example, a space would be added to an address field, can produce a different hash total as a result. And when there is a different hash total, then the receiving program knows that there was a problem in the transmission. Can anything go wrong? Yes. The worst case would be, what if I sent a file and it was altered and the receiving computer did not know it was altered? And this is what this would look like. Suppose something happens to my purchase order. It gets altered in some manner over the network. The receiving program receives the purchase order, it runs it through the algorithm, and it comes up with the exact same hash. This is the worst case scenario, and this is called a hash collision, where two different files will produce the same hash. How can we avoid hash collisions? Well, the answer is to pick a secure hashing algorithm. And here are a few algorithms that have been in use. The first one that came out was called MD5, and it has a lot of hash collisions that are known. It produces a 32-character hash string, no matter what the size of the original file. It was replaced by SHA-1, which was designed by the National Security Agency, and the SHA-1 is likely to have collisions. It produces a 40-character hash string. This was in turn replaced by the SHA-256, which was also designed by the NSA. This has a low probability of collisions, and it produces a 64-character hash string. And as you can see, the hash strings are getting longer and longer. However, the probabilities of collisions are getting lower and lower, as illustrated by the SHA-512. And it has a lower probability of collisions, and it also produces a 128-character hash string. Lastly, there is a whole family of new secure hashing algorithms called the SHA-3 family, and this has to date produced absolutely no collisions. The algorithms produce character strings anywhere from 56 to 128 characters in length, and this has been so collision free that it has been chosen as the U.S. Federal Information Processing Standard in 2012.